What's up, buddy? Let's talk a little bit about how to read a tape measure. Very basic stuff. Not necessarily, well, I say not necessarily welding related, but if you are going to be a welder, chances are pretty good you're going to need to learn how to read a tape measure. And I wanted to make a video to break it down real simple for this first iteration of this. I'm sure I can make some more about reading a tape measure, but I wanted to make it pretty simple and sweet for this first one. And we're simply going to take just 1 inch, the first inch, what a tape measure would look like. We're going to break it down into its different parts, its fractions, and make it easily digestible for anybody who may or may not, have experience with a tape measure. This video will at least get you started on the right foot, and with these simple fundamentals, you can pretty much do anything else with a tape measure, just adding a few whole numbers, converting to feet, whatever. But this is the very basics of it. On your screen, you'll see we have an image of 1 inch tape measure here. We have a 0 to a 1. Is my cursor not popping up? It might not be on the screen at the moment, but I might be able to fix that. We'll see. Can I fix that real quick? If you couldn't tell, this may or may not be my first time using this program with the recording. Do we have settings, properties? What do we got here? It says capture cursor, so maybe it's showing up, maybe it's not. I don't know. Maybe I need to click on it. Maybe that's what it is. Anyways, I'm sorry about that. There we go. Now my cursor is showing up. Problem solved. Let's continue. So we have the 0 to 1 inch measurement here, and on this particular screen, this image that I've created, we have these hash marks. These lines down here are what we're going to call our hash marks, and the numbers associated with those hash marks. This is what you would see on a tape measure or a ruler or a scale, showing these lines and their corresponding measurement on those lines. Now, your tape measure that you may be using most likely not have every single one of these fractions on here, and they especially won't have the decimal conversions on them. That's just there for a little bit of a kind of a little bonus for this particular sheet that I give my students. I wouldn't worry too much about the decimal conversions. We're focusing on the fractions here for the inch. And I'm going to show you a couple of quick tips on how to navigate this 1 inch and kind of read it if you had no numbers at all. If you had no numbers at all on here, we're going to have a little tips to show you just how you would kind of figure it out without needing the numbers. And I'm going to switch over to a very high level program here. Let me switch this screen window over, and there it is. High level stuff here. You may recognize it as MS Paint, but it's very high tech stuff we're going to use here for today. Rather than using a whiteboard on a wall, I figured I'd give this a shot, try it on my actual screen, and see if I can make it work. I've kind of drawn a few lines to get us set up at the moment, but I figured that was a good starting point for how we're going to figure out what the different lines on a tape measure mean. So we'll grab our line tool here, and if you see, I've already set it up. We have a very long vertical line on the left-hand side and a very long vertical line on the right-hand side, and one extremely long horizontal line along the bottom connecting the two. And at the very first one, we have a 0. This would be our starting point, 0 inches. This is where the end of our tape measure might hang off of a piece that we're trying to measure. And then we have a number 1 over here at the next vertical line. That is the same length as the original 0. That's important. Keep that in mind. The 0-inch line is this length, and the 1-inch line is relatively the same length. I tried to draw them, just kind of eyeballing it, but it should be pretty close. And above that, we have our 1 and our inch symbol with the quotation mark there. So they are the same length, and that is for a reason. Every single inch will be the same length vertical line. If we had a 2-inch over here, which I'll put up here in a little while, but it would be the same length. But we're just breaking down this 1 inch first. So between those two vertical lines, I would have another vertical line roughly halfway. I am eyeballing this, so bear with me. Roughly halfway between, oh, where's my line? Did it not let me do it? Let me try this again. There we go. We have roughly halfway between, and if you notice, I'm not going to make this line go all the way to the top. It is not going to be as long as that 0 line and that 1-inch line. It's actually going to be a little bit shorter, and there's a reason for that. This is going to be our half-inch line, and I'm going to make it about right there. You know, it's only maybe about 80% the length of our 0 and 1-inch line. And that is going to be our half-inch line. The half-inch lines are going to be a little bit shorter than our whole number lines. So the half-inch fraction of an inch is going to always be shorter than the whole number vertical line. So we're going to get our text tool. We'll just write, we'll type up here 1/2. It should work if we put it there correctly. And that should be all right. It's working out better than intended. That's good. Okay. So this is going to be our half-inch line. The only thing I probably should have added maybe is a couple of quotation marks, but this is our half-inch line. It is the next tallest line. The tallest lines being our whole number lines. The next tallest line being our half-inch line. And there's only one of them within an entire inch. That makes sense because there's only 1/2 inch within here. So if you had 2 of them, it'd just be a whole number. It'd be a whole inch. So we have a 1/2 inch. Okay, technical difficulty there. Since I'm wearing my headphones and I'm using the microphone attached to my headphones, and I'm not listening to anything, my headphones just default turned off. So that might have cut off for a second there. We're doing this. This is the first video in this format, so I apologize. Please bear with me. So we were at that. What do we have? We have a 1/2 inch here for our next tallest vertical line. So we're going to make some more vertical lines using our line tool here. And it's going to be halfway between 0 and a 1/2 inch and halfway between a 1/2 inch and 1 inch. And they're going to be a little shorter than our 1/2 inch line. They just go a little shorter each time. So again, just eyeballing it here. We'll start our line here, and we don't want it to be the same height. We want it to be a little bit shorter. So maybe about right there. Again, about 75–80% of the length of the 1/2 inch line. And then we'll draw another one between the 1/2 inch and the 1 inch line. Something about right there. Similar height to the one on the other side, 75–85% of the 1/2 inch vertical line. We'll leave it there, and we're going to get our text tool again. And if you can see what we just divided it into, what is half of a 1/2 inch? Give you a second, but I'm pretty sure you guys are pretty sharp on that. Half of 1/2 inch is a quarter inch. Might need to make this text a little smaller as we get a little smaller. Now, just shove that up here. Oh, we put that up to that. 1/4. Yeah, that'll work. Okay, so that's half of 1/2 inch is a quarter of an inch. So we have a quarter of an inch down here. We're breaking it down, half of 1/2 inch. Now, we do have this other vertical line between 1/2 inch and 1 inch, and we are now breaking this entire inch down into fourths or quarters. So this being our 1/4, and this you could technically say is our 2/4. Well, we could put something up here. 2/4 is equal to 1/2 inch, right? So 2/4 is equal to 1/2 inch, but we're not going to call it that. Well, nobody calls a 1/2 inch 2/4. If you get caught saying something is 2/4 of an inch, they might run you off of that job site pretty quick. So you know what? We're just going to get rid of that. Let's see, how can we do that with an eraser? We're not going to call that 2/4 ever, but understand that it is the equivalent of 2/4. 2/4 is 1/2 inch. So if this is 1/4, this is 2/4, which equals 1/2 inch. Then what's this third one over here? Well, if you said 3/4, then you'd be correct. So we got 3/4 of an inch over here. All right, so we got 1/4, 1/2, 3/4, and 1 inch to make the whole thing. Our vertical lines are slowly getting shorter as our fractions are getting smaller. Okay, we have a big old whole number 1 inch vertical line, slightly shorter 1/2 inch line, and a slightly shorter 1/4 inch lines. 1/4, 2/4, or 1/2 inch, and 3/4. And the way these tape measures are broken down, you'll notice it multiplies the number by 2. If 1 was in fraction form, what would that be? Okay, we got 1 over 1, right? Technically, yeah. Technically, that's what that would be. So we got 1 over 1 over here. If we broke that down, don't want to cover that up. So if we just take a quick look at that, though, you have 1 over 1. And if anybody understands their math also, we have in fractions, the first number is what we call the numerator. And the second number is what we call the denominator. If we were drawing it up, like an actual fraction, numerator would be the top number, and denominator would be the bottom number. Let's say we did this again, 1 over 1, and that's kind of what that would look like in fractional form, just one on top of the other. This is the same thing as this. So we have a numerator, okay? See if that fits there, that will. And we have a denominator. And that didn't fit because I didn't make the box long enough. There we go, that'll work. So we have a numerator and we have a denominator. In this case, for a whole number would be 1 over 1. Now let's kind of see a pattern beginning here already, and that is that this 1, if you multiply it by 2, is going to equal the next shortest line. That's a 2. So it's 1 over 2. 1 times 2, this denominator, we're multiplying the denominator by 2, and it's giving us a 1/2 inch. 1 over 2. Okay, if we continue that pattern, we take this 2 and we multiply it by 2. It gives us a 4. And that's going to be the next fraction that we're working with here in this measurement. So we're going from 1 times 2 equals 2. 2 times 2 equals 4. And I just wanted to give you, see that pattern so you can probably recognize maybe what our next hash marks fractions are going to be. First, let's make our hash marks, which are going to be about 75% the length of this one. And we put a line down here. Yeah, about right there. That looks pretty close. Maybe a little bit off, but we're not going to split hairs here, although that's kind of what we're doing with these hash marks. And then we're going to put some more over here in between each of the previous lines, in between each of the previous lines here that we've created. Okay? We get that one there. We get another one in between here, about halfway. Boom. All right. And one more, and roughly there. Try to get these things at least straight. Okay. So continuing the pattern that we were talking about, we had 1 times 2 equals 2. That gave us the denominator for our 1/2 inch here. And then we broke it down into 1/4 inches. 2 times 2 gave us our denominator, which is 4. All right, if you guys are following along pretty good, and I know you guys are sharp, 4 times 2 will give us our new first fraction over here. 4 times 2 is, of course, 1/8. 1 over 8. Okay, I don't know why this thing is always so long. That's okay. Um, so now we have 1/8 of an inch is our next hash mark length. They look like they kind of get shorter, but that's okay. 1/8 of an inch. So we got all the way down from 1 inch of the hole. Half of that is half an inch. Half of a half inch is a quarter of an inch. And half of a quarter inch is an eighth of an inch. But we still need to fill out the rest of our hash marks here. And we know these shorter ones are eighths. These are our eighths of an inch. Another pattern you may start to notice here if you look at the numerators and the denominators is that the denominators, the bottom number or the second number in this case, what's the pattern here? We got 2, 4, 8. Not only is it multiplying, but they're all even. And they're going to have to be even. Your denominator is always even. 2, 4, 8. There's no 6 because that's not how this works. It's a little different. There are 6 of fractions, but we're not going to get into that. Don't even worry about that. 2, 4, 6, 8. No 6. 2, 4, 8. But these are all even numbers. And the numerator, take a look at that. Numerator, oh, look what we got here. Are there any even numbers in the numerator? Oh, well, that kind of defeats my denominator thing here. Ignore that because that's not really there. Sorry. So our numerator is always an odd number. If you notice that, our numerator is always odd. And it's going to go that way when we get to the hash marks. It's going to go by the odd numbers. If you remember your odd numbers, 1. So if this is going to be the next odd number, it's not going to be 2/8 because 2/8 is actually a quarter inch. So we're skipping that. We're going to skip that because we don't call it a 2/8. Again, if you do that, they're going to look at you funny. So we're going to go from 1/8 over to 3/8. Okay, 3/8. Sound good? If I wanted to put up another one over here, what comes after 3 in the odd numbers? We have 1, 3, 5. 5/8. All right, so far so good. And then 1, 3, 5, 7. 7/8. Odd numbers always at the beginning or technically at the top because that is our numerator. 1, 3, 5, 7. Could go to 9, but that's going to go beyond an inch because 9/8 is higher than one whole number. So we don't go to 9. We're going to stay under the eighth when we're sticking within our first inch here. So we have 1/8, 3/8, 5/8, and 7/8. Numerators are always odd. And our lines got a little shorter. And so that's how you're going to read down to these eighth inch fractions. And we do go one more step further. Tape measures almost always will go down to the next level of fractions. So we are going to need some new lines that are going in between our eighth inch lines. So we're going to make a few of those. It's going to be several of them because there are so many now. But got one between 0 and an eighth, between 1/8 and a quarter. And you've noticed these are shorter lines. As our fractions get smaller, our hash lines get smaller. And as we go through here, just keep count of them. If you notice, you can start counting them, and you can even count them whenever you're doing measurements. But the idea here is just to recognize them by the length of the line and where they're sitting in between the other lines. That way you don't need these numbers on top of them. You don't need the labels. And that way you can just recognize the fractions. You'll memorize this. You'll recognize the fractions by where they are in accordance to the 1 inch and the half inch and maybe the quarter inch and the 3/4 inch. And the lines, the length of lines, okay? When I'm seeing these, I'm like, all right, I need 3/4. Well, I know it's going to be not this first one, but it's going to be the next kind of fairly long line, shorter than a half inch, but taller than an eighth inch. That's going to give us the 3/4. Okay? But I'm getting ahead of myself. Now we have to do our multiplication here again, We had our whole number. 1 times 2 is 2 for that denominator. 2 times 4, I'm sorry, 2 times 2 gave us 4 for this new denominator fraction. 4 times 2 gave us an eighth. An eighth is half of 4. I'm sorry, an eighth is a half of a quarter. And so for this next hash length here, we're going to do 8 times 2, and that's going to give us this here. I might have to make this text even smaller. Not too small, though. I want to be able to read it. Let's see if we throw it down to 36. Okay, let's put in 1/16. If you guessed 8 times 2 being 16, might have to move that over a little bit. There we go. Okay, and that is half of 1/8 is a 16th. Fractions are a little bit different whenever you are cutting them in half. You get a larger number on your denominator, but your numerator stays the same. And again, our numerator is still odd, and our denominator is still even. And all the numerators for these newly created 16ths of an inch hash marks are going to be odd. Seeing that pattern, we have 1/16, so then our next 16th hash mark is going to be 3/16. Yeah, all right, see that? And we'll get another one over here. Odd number first, 5/16. And I think you guys are probably picking this up pretty quick. 7/16. 9/16. We just passed the half-inch mark. So we do know that half inch in 16ths is 8/16, but we don't call it that. Again, we simplify it. We convert it to the lowest fraction here. So 8/16, you can still divide that down to half an inch. All right, let's continue. 11/16, odd numbers. What's the next odd number after 11? Probably 13. Not probably, it is. And then the last one is 15/16. We don't go beyond 16, otherwise we're going past our inch here. Okay, so that is how we break that down. We have our hash marks for our 1 inch on a tape measure, and all the hash marks slowly got shorter as the fraction got smaller. The denominator gets bigger as the actual fraction gets smaller. Started off with these long vertical lines, 0 inch, 1 inch. Got a little bit shorter for our half inch. A little bit shorter for both our quarter inches, 1/4 and 3/4. And then we got even shorter, 1/8, 3/8, 5/8, 7/8. And then we got down to our shortest hash marks, typically on a tape measure, which are 16ths of an inch. 1/16, 3, 5, 7, 9, 11, 13, and 15/16, making up the 16th hash marks on an inch that you would see on a tape measure. And so this is how you would break that down. Again, remember, all the numerators here are odd, and all the denominators are even. Keeps on going. You go on, if you can maybe take a guess, if you had more smaller hash marks on here, which some scales do when you're trying to get down to good accuracy, what would those be? We're not going to put those on here, but remember how we did this? 1 times 2 is 2 for our denominator. 2 times 2 for our denominator is 4. 4 times 2 is our denominator for 8. And 8 times 2 is our denominator for 16. 16 times 2, our denominator for 32. Those would be 30 seconds. We're not going to get into those, but that is what the next level would be. Typically not on a tape measure that you would be normally using. So that is the bare basics of reading a tape measure, breaking it down like this. Now, if you want to, you can kind of take one of these screenshots, cut it out, whatever you want to do. print it out and kind of keep that as a little cheat sheet. It's not bad. I have that other image here too, um, which he has. I mean, it's the same thing, but it has it also the decimal conversions if that interests you. Um, but that's what we're going to cover for now. Uh, we'll maybe try to pull up some potential sample questions at some point, but I didn't want to get too ahead of myself today. I just wanted to put this quick one together for anybody who is interested in just learning the basics of a tape measure. It's not really a welding video, but it is, because if you are going to be welding, more than likely you're going to have a tape measure in your pocket, ready to go to make sure you're cutting things, welding them up to the right lengths, all that sense. So, uh, not specifically welding, but very welding related is reading a tape measure and a very vital skill to have. So hopefully you learned something by watching this, and we'll try to put into some more applications maybe next time. And yeah, thanks for watching. I'm glad you're here, kind of taking in this information, and you are. I think you're going to be a better welder because of it. Keep it up. Have a good one.